Okay, this is 1.1 for Rust. We're going to be creating a source file for our software and compiling it. So let's create a file called main.rust, or rs. So we're going to want to write this out. So all this does is print hello world to the screen, and that's pretty traditional for writing and learning a new language. Alright, the command to compile C is Rust, or compile Rust is rustc, and we're just going to, as a parameter to the command, we're going to send it main.rs, the source file we just wrote. And I need my bash instance doesn't have rustc as a command, so I just need to start a new instance. Okay. Here, this is our directory. Rustc, main.rust. What? I'm so confused. I'm so confused. Rust, playground, temp. Okay. Alright, and then on Linux, to execute a file, so we just compiled the source file, main.rs, and then the compiler wrote to this main file called main, which is our executable, where our machine actually starts to execute the instructions that were compiled from our source. So in Linux, you just do / and then the name of the executable, and this is what it looks like when our program is executed. So to break this source file down, we have a couple things. So fn declares a function. Main is the name of our function. We gave this function the name main, but main is also a special function that is ran first. Calling something main tells the compiler that this should be ran first when the executable is ran. The parentheses are for parameters, and to define our function, we use the curly brackets. Everything inside of these curly brackets is big or as small as we make it is the function body. So then in our function, we put a standoff between the instructions in our function, and in Rust that's 1, 2, 3, 4 spaces, which is conventional. So once we have 4 spaces, we can write our first line. So if we write print ln bang, this is a macro which is special compared to other functions, but we don't need to know about macros at this very moment. And then hello world is just a string, which is, the compiler knows that the text inside of the quotation marks is a string because it uses the quotation marks. If we didn't have quotation marks, the compiler would get confused and interpret this as just code. But because we have quotation marks, the compiler knows that it's a string literal. And then just like the parentheses in our main function contains any potential parameters, we push this string literal to these parentheses to say this is a parameter of the macro that we called. So, and then when you end a line in Rust, you do a semicolon just like C. And that's every piece of that. Okay. So how come when we compile, it doesn't immediately run hello world? In some languages, compiling or looking at your source code in whatever form that may be is synonymous with running it, like in Python, where pretty much as long as it's grammatically correct or syntactically correct, you're going to run the source while you're looking at it. Here we are taking the source file and compiling it to bare metal machine code. And then we execute separately. And the benefit of this is that we don't need Rust on our machine to execute this. There's no overhead in runtime when we execute main. And the downside is that you have to do things separately. And also, depending on the language, not compiling in the first place would give you a more seamless it would make it more portable, or at least it's portable in a different way. So it's all about trade-offs in language design. Okay, now if you use C and C++, you're probably used to using GCC and then whatever source file you have, and then doing the exact same thing in the exact same order that we just did. But this becomes finicky. And ideally, we're not using Rust C to execute. We're using a different tool called Cargo, which will be explained later. Okay.